Hello and welcome. Today I want to fix this broken soundbox. It's my daughter's soundbox and she was kinda rough on the USB port, so it broke and it's not charging anymore. I've already repaired this once. At this moment I ripped the pad and fixed this with the jumper wire, but today I want to do it the right way. First we remove the sticky bottom pads and then we unclip the sides. After that, we remove the microSD card and unscrew the side screws. Now we'll lift up the shroud and here we will find 4 other screws. Once the screws are out, we need to remove the black cover and can separate the housing in the middle. I need to find a good spot. And this is how it looks inside. Here you can see the battery, the speakers and the board, and also the broken USB-C port. I will disassemble this further and will meet you when I took this apart and removed the USB port. Hello and welcome. Today we will try to fix this ripped pad from the soundbox. Sorry for this shakiness. This is very high zoom level and the components are really tiny. To set it into perspective, you see here under the microscope an USB mini port, a toothpick, the dental pick and the tweezers. And now you see here how it's looked in real life. It's really tiny. Now I'm scraping off the trays to be able to solder the new pad to the trays again. I ripped the pad in the previous repair attempt and now I'm trying to fix it by replacing the pad. In the previous repair attempt I used the jumper wire, but this time I'm trying to fix for the first time a ripped pad. Now I added a little bit of solder and want to tin the trays. My hands are really shaky, but it's a learning curve to be able to hold the hand still. Now I tint the trays and try to add the pad. The pad is a little bit huge, so I need to cut a little bit down. Any movement of the desk, any breath makes the board shake, and it's very, very difficult. So I'm trying to place the new pad in the right position. I scavenged it from the previous USB port and ripped it out of the socket. So it's not a real pad, it's a really, really thick chunk of metal. It's unusual for this repair, but it's the best thing I found around. And I think it's quite better than just a raw cable, which is contained of many small cables, and it will be much difficult or much more difficult to proceed it this way. This part is very, very tricky because I'm trying to use my left hand. I'm right-handed, and it is very, very difficult to hold the hand still. Also, there's a problem with the depth or view of depth during the or through the microscope screen. It's not a real microscope, it's a Adenson, I think, AD409. So it's really, really good at the zoom, but you miss the whole depth of view, and so you cannot really see how far you're down. So basically, if you're 1 centimeter or 1 millimeter above the board, you don't really see that you hover above the board. Now I soldered somehow the pad, but it's not aligned right, so I'm trying to bend it over so it fits to the groove. I hold it with my pick and put it over. Yeah, great. Now we have 2 ripped pads. Good job. 99 little bugs in the coat. Take one down, pitch it around. 128 little bugs in the coat. Oh, I didn't expect that, and I didn't expect that it would be so difficult. So we give it a try. Back to the roots. Now we have to fix 2 rib pads. At this moment I was really frustrated and I was about to throw the board away, but never gonna give you up. So the tray is also ripped a bit, so I need to remove the ripped part. For this task I use a scalpel because it's very sharp and it's worked really, really good with that. Now we have to scrape the traces again to make a space where I can solder the new pads to the traces. Here use also the scalpel, it's very sharp. There is no real need for the grinders because yeah, they are quite nice, but a scalpel works really, really good too. You see in 2 or 3 little scrapes and the trace is blank, so you can solder to it. Now I use a little bit of isopropyl alcohol to clean up the working space. Now I'm trying to place or to align the pad in place and make a little measurement if it's too big, too small, or if it needs a little bend. Now I'm trying to press down the pad with my left hand in the tweezers. And bend the bottom part so it's aligned with the trace. This is not quite there as it should be, so I keep bending. Now it looks like we are almost there. I cut at the top part so the pad gets a little bit shorter and match better to the missing pad. Now I'm trying to flip around the pad so the bottom part shows in the right directions, but it's quite a tricky task. And now I see it's not bent enough. Due to flux, everything is a little bit sticky and difficult to keep in place. So if I touch it with the tweezers or with the toothpick, dental pick, sorry, it sticks to that and loses its place instantly. As said, it's my first time, so I keep struggling and searching for the better tactic to keep it in place, to be able to solder that. I'm really struggling with my left hand because it's very difficult to keep it steady and move it this precise as needed for this task. After the work is done, I will show you a picture with a coin or with a match so you can see the real dimensions in the real world. Because looking through the microscopes, everything looks big and easy, but in real life it's microscopic. Now we have a second pet, which we ripped previously, and this one also doesn't want to stay in place. But we keep trying. I'm trying to flip this pad so the bottom part shows in the right direction, but it's way difficult than you can imagine. Okay, I decided to change the strategy and add a little bit of flux, so maybe due to flux it sticks better. I also have to tin the traces so I can solder so I can solder the pads to the traces. This time I decided to go for it and just try to solder it somehow. I take my dental pick to press down on the pad and try to solder it. And it somehow worked. Great, but now we have this big blob on the bottom. It's way too much, and now we loosen the blob, but now it's spread over the bottom part of the pad, and basically it makes a short to the ground pad, and we have to get rid of that. So I'm trying to cut it with the pliers, but it's too small for that, so it doesn't really work. Now I try to cut it with the scalpel so I can lift it off, cut it off and then lift it. But as you can see, I can't cut through, and I don't want to get really hard on it to rip anything other apart. Here, try it again to cut it off. Wiggle it a bit. try it again with the pliers, and now it's almost ripped again. So I give up and remove the pad again. Now I cut off the bottom part, or I shorted it, and now I try to solder the shorter pad to the same place as before. It's very hard to position the pad, so I flip it and try to realign it. This looks like the perfect position. Now is the question, can I hold it down and solder it? And just by pressing down, the pad moves out of the position and I have to realign it again. So, but we're gaining experience here. Now I bend it a little bit more so it aligns better with our trays. But we are gaining experience here and training steady hands. Now I just try to solder it, and it looks not too bad. I have to be careful not to solder it to another pad so we don't rip a third one. We are good at that, as you have seen, as you already seen. But this times it doesn't work either. Great. But it's no time to give up. We will try it again. Because the other ones somehow get it soldered, so somehow this should work. We just have to discover how. Now I try to hold it from the top so it's kind of fixed, and solder it from the bottom. This was a total luck shot. So basically one pad is soldered in place and it's looking not too bad. I'm cleaning up to have a better look. but it looks good to me. Hey, one pad to go. Now we add a little bit of flux again so we can solder the second pad in place. Now it looks really messy, but this will get better later when the socket or when the USB socket is in place. Now we try to position the second pad. The bottom part looks in the wrong direction, so I try to flip it so it's looking to the left, not to the right. But due to the sticky flux, it sticks everywhere and doesn't stay in place. Really annoying. Now I try it with my right hand because the left hand is not precise enough with the tweezers. And now it's kind of in place. I want to hold it down and solder it. And it's bad. Try to desolder it. Now it's soldered to the left pad and it's soldered to the bottom pad and it's soldered everywhere. Einsatz mit X, das war wohl nix. Okay, let's try it again. I want to mention that this is a cheap €5 part and I have no idea why I'm doing this to me. This is insane. This is madness. I wished I have thrown it away an hour ago. It's insane how difficult this is. If you watch other pros soldering and restoring pads, it looks quite easy, but if you try it yourself, everything is shaking, the hands are not responding the way you expect them, they are not holding still, and the parts are behaving really weird, sticking to everything, soldering to everything, but not there where you need it. This is bad. I hate it. Luckily the microscope has no microphone, so you cannot hear me swearing, crying and yelling. This exercise gives me so much respect for the pet restoring solder on YouTube, but also for chirurgists, which are basically doing the same with flesh, needle, and wire. We will not give up. Giving up is not an option. This is Sparta. Okay, I try to hold it down and with the tweezers and solder it now. Ah, great. Now we have a big blob on the bottom, and this will be not possible for us to put the USB port on there because it's a big huge bump and the port will not be sitting the way it should. Okay, try to solder the pad. Looks not too bad, but the pad is sideways as you see and it's not laying flat. I need to flatten it to be able to solder to it right away. And it broke off. And it's gone. Wooza. Wooza. I'm meditating and try to keep my sanity. Here's a good example that the tip is too small for the wicking task and it cannot transfer enough heat to heat up the solder. Now I'm using the tip directly, but as you see, the solder will not flow. We need flux so the solder can flow into the wick. Although the solder is liquefied, it's not absorbed by the copper wick, and when we add the flux, you can see how the solder flows directly to the wick. Okay, now we fix the mess. Back to the second pad. Why on earth I'm doing that? Why? I have no idea. But we started it, we have to, and it's gone. Where is it? Yoo-hoo! And there is it. Yeah, if you going too hard on the tweezers, the parts you're holding just disappears, as somebody says, in the 9th dimension, and you will never find it again. So we are lucky here that the part reappeared somehow. Okay, maybe I can use the wires, but if they split, they can solder to the other pads and it would be pain in the ass again. So a solid pad is a much better idea here, because although it's difficult to place and keep in place, it cannot split up and it stays as a pad in whole. I'm looking for a good position how I can hold it in place without flipping it away and pushing it away. I cannot even really hold it or push it down without moving it out of the way or moving it to a wrong position. Each small touch makes it move directly out of the way. I cannot pick it. I cannot hold it. Everything is shaking. Great. Okay, now I changed the type of tweezers. I got the ones with the bent front, so it's a little bit easier or more comfortable for my hand due to the bend on the tip. If you're tired watching this, I can totally understand that, because it's pain in the ass, but this is how it is, and this is how a beginner, or how it would look like for a beginner if you first try to fix your pet. If you don't have a luck shot for the first time, it will be pain in the ass, and I'm showing this video so you are not thinking that it's quite easy task. So you can see for the first time it takes a while. You need to get comfortable with the shakiness, with the not right positioning of the hands, and the hands are not executing your commands properly. So basically they are not doing that what you want them to do, because it's too filigrane. At this point I thought a million times about giving up, but we in Germany don't do that. It's not allowed. It's verboten. Aufgeben, verboten. Ha! I soldered it to the wrong pad. Ha! Again. Oh, damn it. Now I soldered to the anywhere, and now it's stuck on the soldering iron. And again, maybe I can solder it while holding it with the tweezers. As you can see, it's stuck on the soldering iron, and then it's stuck to the tweezers, and then it's stuck to the wrong pad, and now it's gone missing. And here it is again. Now I need to calm down, reposition it, and retry. And now the iron is cold. Damn it. I'm getting it warmed up. Take a little bit of soldering. Yes, it's look good. It's looking good. I think it could work. Hold in place and it's gone. Okay, try. Come on in place. This is madness, this is insane. Okay, don't rip another pet. Please don't rip another pet. Out of the way. Okay. I think this cannot work this way. We need another strategy and have to think about it, how we can get it to work. So basically I need to position them and I need to solder them. The soldering is no problem. Due to flux, the solder flows and solders the pad to the trace. So we have no problem here, but how we can align them and keep them in place so they are not running away when we try to solder it. I have an idea. So retin the trays, and what we're gonna do is using a solder mask as a kind of glue. I thought about using glue itself, but you cannot easily remove it once applied. So I think the soldering mask is maybe the better choice here. Let's give it a try. First I need to position the pad again on a dry surface. This should be easier because it's not so sticky anymore, so I can move it in place. Okay, this looks good. Ah yeah, Happy New Year. This was a rocket from somewhere in the neighborhood. Okay, let's apply the soldering mask at the top. It's no problem that it's touching the pad to the right, because if it's blocking something or problem, we can scrape it away later, like the soldering mask on the traces. Okay, now we could position it, and this looks good. And now we have to cure it with UV light. I don't know which is the right one, and I don't know the curing times, but A little bit should be enough just to cure it enough so it's staying in place while soldering. This UV light doesn't seem to have any effect, so I choose another one which I have laying around. Hopefully this one helps or does the cure. The cure takes a while. If you want to accelerate it, you can heat it with a heat gun or with a heat soldering station, but you can take your time and cure it with just with the UV light. You can now test it with a pick or with your scalpel if it's already solid. And it feels solid. Okay. Just for the safety a little bit more. Now before soldering we want to align the second one also, so we can solder it in one go. Because for soldering we need flux. Flux is messy, so once flux applied we cannot use the soldering mask because it will not bond with the bottom of the board, and flux will be something of a layer in between, and the flux will not, the soldering mask will not stick to the board. So if you're a beginner, you see the start is really hard. Although it looks like, or it looks easy if someone experienced doing this job. It looks like almost nothing, but now I see it's a very complex task, and you need to be very skilled to make it fast and precise, as it's mostly shown in the other YouTube videos. Okay, the alignment looks good. Now I place another drop of the soldering mask and try to cure that. Okay. Holding in place and dripping the mask on top doesn't work or haven't worked, so we put the mask in place and push the pin inside and cure this afterwards. Soldering mask is a little bit sticky, so it's kind of holding it a little bit in place. Okay, it's in place by now. I try to push a little bit down so it's completely submerged in the soldering mask, but it was already all the way down, so we continue with curing. I want to get sure that it's all the way cured so it stays during the soldering process in place. Okay, we'll check it, and it looks solid. Okay, the pads are fixed with soldering mask, and hopefully they stay in place during the soldering process. We add a little bit of flux again. For safety, we push the pin down and start the soldering right away. And it looks like this works. The right pad is not attached to the trays. As you can see, it moves So I need a resolder. Yes, you see it moves left to the right, and the other one is solid. A little bit of flux again. And we're trying to fill the space between the pad and trace with solder so we have a solid connection. It's not there yet. I need more solder. The problem is if you have a really pointed tip, it cannot suck up that much solder and cannot expose that much solder to the pad. Now I'm checking the connection, and it looks solid. The trace to the pad is working. There is no short between the pads. The path from the pad to the transistor or resistor is also working. Yeah, it looks actually good. Nice. Now we have to give it a good clean. I'm wiping from top to bottom so I do not rip the weak pads. This is actually looking not too bad for the first time. Now I take the brush to scrub down the cotton leftovers. As you can see, there are strings from the cotton. We need to get rid of them. Now I'm blowing air at that to get it dried, and now we have to reinforce the pads with solder mask. With this reinforcement, we make the pads stronger so they cannot be ripped that easy. And the second benefit is that they are isolated from the USB port, so they cannot be shorted out by touching the USB port. Due to the additional pads, which are thicker than the original ones, and the additional solder, we have a bump on the board, so they will be touching the USB port, and because that the USB port is out of metal, they can be shorted out. The soldering mask prevents it from shorting and holds them in place. Now we have to cure it again. Okay, once the cure is done, we can check it. Everything looks solid. Now I can put or try to put the USB port inside. The fixing holes are looking clean. Now we can place the new port in its position, and as you can see, the pads are aligning perfectly. Our soldering mask is no problem for them, so we can solder the USB port in place. Now we do a little bit more soldering mask to cover it completely up and make it rock solid, so it never comes apart again. Now turn the board around so we can have a better look at the pads and the board from behind, so we can solder the pads to the board. Why we solder the pads first and not the anchors is because the board is not really flat, and we have to ensure that all pads are soldered perfectly so they have contact, and then we solder the anchors according to the position of the port. If we solder the anchors first, we maybe not be able to solder all pads how they should be soldered. I push the USB port down so it makes a good contact with the pads. Now we solder them one by one in place, and now we made a huge mess and bridged the pins 3 and 4. This is usually not a problem, but due to the small soldering tip, it's not sucking up that much solder, so we have to touch it multiple times so the solder comes apart. We also use flux so the solder flows to the pads itself. Looks like the bridge is gone. Let's have a look from an angle, and we see no, it's still there. We need to continue that. And the best friend for fixing bridges is flux. So we add more flux. Now it looks like the bridge is gone. Now we can solder the anchors of the USB port. It's not really working from this side. So we need to flip it over. Also, the tip is way too small for this task, but I don't want it to wait for the cooldown, so I can replace the tip. So I continued with this one. you can see how the solder is flowing through the hole while you're heating it up. This looks good. Now we see there should be no bridges. Now we check, this one is solid, this one is also solid. This one is moving with the pad, it's okay. But this one is moving freely, so it's not soldered properly. Because the pin is not touching the pad. This isn't solid yet, it's still moving, so we have to keep soldering. Now the iron got cold. So that's why it's not soldering properly. Not heating anything. You see? So I have to turn it on again. Now it's hot again, and we can solder the pin. Now it's solid, and we can proceed. So every pin is fine. Now we can clean up and continue. Soldering looks good, but I wanted to remove the big blob, and as you can see, without flux the solder is not really flowing. It's making these pointy pieces, but it's not flowing, so I can't remove the too much solder. So now we add a little bit of flux, clean our iron, and this should work. Now you see that the flux is more willing to flow and make this shiny round solder joints. And this is fine. I'm just cleaning up and going for the test. On the bottom it looks also fine. We add a little bit more of solder mask to fix or to keep the moving pad in place. Let's take a little bit more to be sure that there is no moving in the future and the pads are really strong bonded to the board. Also, we need to cure this again for a couple of minutes or maybe 1 or 2. Now let's test the result. Does this work again? I'm inserting the micro USB cable, and if it's working, the charging process should start. Yes, indeed. We see a red light. Now we can start the device and it's working fine. At least it's charging again. And it wasn't before because of the broken USB port. Now I already assembled the device completely to the final state, and the kits are kind of rough on the USB ports, so I found a solution for me. This is not a sponsored product, I use it my own, I bought it with my own money. It's an USB adapter for USB-C, and it has tips which are magnetical. There are USB-C and USB-A ports. Basically, you connect your cable and the tip is holding by a magnet to this adapter. So this is how it's looking like. Here's the USB-C tip I'm using for the other devices. Your tip stays forever, or how you want, into the device itself, and the adapter is onto the cable. As you can see, the cable is holding magnetically and you cannot rip the port out. The magnets are strong enough to hold it in place, but weak enough not to rip the port out of the pads. And so you can have a longer lasting device by keeping the USB port healthy, and so it cannot wear out anymore. I also use it on my phones with USB-C. Simply connect and charge, and the nice effect is that you have one cable for multiple devices if you want to charge them. I hope you liked this video and I hope to see you the next time on my channel again. Bye bye.